Hey, welcome to Grade 11 Physics. I'm Mr. Dewick. You're going to see me for some of the videos that you watched this year, and you're going to see Mr. Fast in some of the other ones, so you'll see his face soon enough. This is the very first part of the Grade 11 Physics course. Most of this is review from math courses, review from your grade 10 science course, and so we just want to make sure that you have those things in your back pocket before we get on to the actual physics. We like saying at the beginning of the course here that the physics hasn't started yet. These first few lessons, this is just background stuff, background skills so that you can understand what we're talking about when we actually get around to the physics. The actual physics is going to start a few videos from now. So let's start with scientific notation. Okay, we need this because sometimes in physics we talk about really tiny things, or we talk about really large things, and it's just not practical to write down the number 471,657,000,000,000 whatever all the whole way out. And so we use scientific notation in order to, write numbers reasonably. And so when you're writing scientific notation, you're taking standard form, which is the actual number, however many decimal places it has, and you're shortening it using a power of 10. Okay? And so we're going to convert 315 million, I think that says, to scientific notation. Okay? And so what we're doing is taking decimal places and storing them as powers of 10. So right now our decimal place is right over here, and we want to store a whole bunch of these tens in an exponent, in a power, instead of in the standard form of the number. So if I move the decimal place once this way, now the number that I'm working with is no longer 315 million, now it's 31,500,000. Okay, but I've taken a 10, and now I need to store it someplace. I need to store it in the number. So now it would look like 31,500,000 times 10 to the power of 1. Okay, so if I move the decimal place once, now I have stored that 10, that decimal place that I moved, as a power of 10. But writing this, what I've just written here, that's really no better than just writing standard form. So whenever we're writing scientific notation, we try and bring it down as simple as we possibly can. Okay? And so we will actually want to move the decimal place 1, 2, 3, 4, 5, 6, 7, 8 times. This is our convention, that we always want to have the decimal place after the very first digit, or last digit. I'm going to say first digit. So our number is going to be 3.15. That's going to be the digits in our number, and then in our power we are going to store all of the times that we moved the decimal place. So I think I said that we moved the decimal place 8 times. And so that means we're going 3.15 times 10 to the power of 8. Okay, so all of those decimal places are just stored in this 10 to the power of 8. That is really useful when you're working with enormous numbers like the mass of the sun or something like that. That you're going to get to in grade 12 physics if you choose to go that far. It's just not practical to write out the whole number. So we can store it this way. If you are moving the decimal place the other direction, like this one, 1, 2, 3, 4, 5, 6. So this is a really small number. I am borrowing 6 tens in order to make this number 4.6. Okay, so instead of writing 0.00000 however many zeros for 6, I want to just write 4.6, and then I want to tell you how many tens I borrowed. And I borrowed 6 tens. So my power is going to be 10 to the power of -6. That tells you that I took 6 tens in order to make this 4.6. I had to borrow them in order to get out of the really tiny decimal places. Okay, so if you've got a large number, you're going to see a positive exponent. like this one, or a positive power. And if you have a really small number, you'll see a negative exponent on your power of 10. Now let's just do it the other way one time, where we're converting a scientific notation to standard form. So this -9 here says that we borrowed 9 decimal places, or 9 tens, in order to make our number 6.35. So 635 are our non-zero digits, and then I borrowed 9 tens. And so if I started here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is where it goes. Okay, and so what's usually easier for me than drawing this weird squiggly line here is that if I'm moving the decimal place 9 times, that's going to be 1 move to the left of this digit here, 1 move to the left of that digit, and then that takes care of one of the decimal places. And so then I need to do that. I need 8 more moves. So that's 8 zeros. So if I have 10 to the -9 as my power of 10, then I need 8 zeros. 4, 5, 6, 7, 8. Then I need 8 zeros there. Of course, there's one more 0 on the other side of the decimal place, because we usually don't start a number with a decimal. You can also think 10 to the -9, that's 9 zeros, including the one that goes on the left of the decimal place. That works totally fine as well, in order to make sure that you space them right. The second part, when you are going to type scientific notation into your calculator, it's important that you do it in a specific way. Sometimes it doesn't really matter how you type it in, depending on the operation that you're doing, but it's a good practice to always do it the same way. And so I'd like you to get your calculator in front of you. If you don't have it right now, you should probably pause and go and find it. Have you found it now? All right. So this one's mine. What you're looking for is either an EXP or EE button. Okay, so these two things over here, EXP or EE. Sometimes there's a times 10 to the power of button, times 10 to the X or to the Y or something like that. Sometimes you'll see a button like that on your calculator. Same thing. On mine, I want you to see right over there. It's backwards for you. Thanks, webcam. But it says EXP. Okay, and that means times 10 to the power of. And so when I'm typing in 2.81 times 10 to the power of 8, what I type into my calculator is 2.81, and then I press my EXP button, and then I press 8. 2.81 EXP 8. This EXP types in the times 10 to the power of for you, and it makes sure that this 2.81 and this times 10 to the power of 8 stay attached to each other. Every once in a while, in very rare circumstances, BEDMAS messes that up and separates the two things. That usually only happens if you make some sort of mistake in the order you're pressing divided by or something. But still, this is going to save you some mistakes. Okay, so do it that way. And then if I'm trying to multiply this whole thing out, 2.81 EXP8, and then I'm going to press times 6.38 EXP 3. That's my calculator. Maybe yours is EE instead of the EXP. Maybe yours is times 10 to the power of. That's fine too. It's going to do the same function. It's going to put them together. Okay, and you get 1.79 times 10 to the 12. So I'd like you to try that yourself, just to make sure that your calculator is actually working the way that you expect it to. Okay, so try it out. See if you can actually type those things in and get 1.79 times 10 to the 12 out the other side. Then, when you do the same thing here, times 10 to the power of 4, divided by this thing times 10 to the negative 3, you should get 2.41 times 10 to the 7. You should try that as well. Now, your calculator is not going to say that because it can actually fit all these digits in. It doesn't need to use scientific notation to display the whole thing. And so you'll actually probably see 2, 4, 1, 0, 3, 8, 4, 6.15. And if you got that on your calculator, you did it right. Okay, but give that a shot, please. Okay, unit conversion. This is also kind of a background skill, but it's one that's very, very important in physics. So we use units on pretty much everything because physics is a science that's talking about situations. So we're not just doing operations with numbers like often you do in math. We're doing operations with quantities. So we're multiplying 5 kilograms by 10 meters per second squared. But it has to be units that we're working together. And so what happens if instead of 5 kilograms, you're given 5 micrograms as your number? You need to be able to convert one unit to another unit. Okay? And so that can trip people up if you've been kind of trying different methods of converting things. And so we want to give you one method that always works. So hopefully this makes sense. So we're going to convert some units from one to another using a very specific method. Remember these things. 1 kilometer is 1,000 meters. 1 hour is 60 minutes. 1 minute is 60 seconds. We can also point out that if 1 hour is 60 minutes and every minute is 60 seconds, then 1 hour is 60 times 60 seconds. 60 times 60 is 3,600 seconds. That is something you're going to use all the time. Okay, so let's convert 100 kilometers to meters. You might be able to do that just right off the top of your head because every kilometer is 1,000 meters. And so 100 kilometers times 1,000 meters each is 100,000 kilometers. Done. But there are going to be more complicated versions of this. So using a simple example, I want to give you the method that we generally use to convert units. So we're starting with 100 kilometers. We're going to multiply by the conversion ratio or conversion factor or whatever you want to call it. That's going to get us from kilometers to meters. Okay, so let's consider 100 kilometers to be a fraction. That's just 100 kilometers over 1. And there's no unit on the bottom. So this is just kilometers is on the top of this fraction. Okay, so if I want to change kilometers to meters, I'm going to need to cancel out this kilometers on the top here by putting a kilometers on the bottom of my conversion fraction or conversion factor. And if I want to change it to meters, meters should end up on the top of that fraction. And so what this conversion fraction here is a ratio of one unit to another. And so in here I would put 1 kilometer is 1,000 meters. Okay? Or I could have, if I wanted to, put 1 meter is 0.001 kilometers. I think that's the right number of zeros. Either one works totally fine. Doesn't make a difference. But we're putting in a conversion fraction or a conversion factor that allows you to change one unit to the other. So then we're just multiplying fractions. 100 kilometers times 1,000 and 1 times 1. But the kilometers, being on the top and the bottom, gets canceled out. And so what you end up with is 100 times 1,000, which is 100,000 meters. So it's not so bad when you're just doing one unit to another unit. Let's try the 5 hours to seconds. So we multiply it by the ratio that compares hours to seconds. So if this is a fraction like this, hours is on the top, and so I want to divide it away. So I put hours on the bottom, and I want to change it to seconds. Now, I could change it to minutes first, and then change the minutes to seconds. So I could actually do this in 2 steps, or given the fact that we know there are 60 times 60 seconds in an hour, or 3,600, we can just go straight to seconds. 3,600 seconds per hour. And now, because we've gone straight from hours to seconds, the hours gets canceled out. We're left with only seconds. And that gives us 5 times 3,600, which is 18,000. 18,000 seconds. That's 5 hours. Lastly, convert 4 kilometers per hour to meters per second. And here is where this method really is helpful, is really powerful. You could probably do these 2 conversions you just saw without using this method, but when you are getting into compound units like kilometers per hour, then I find that this organizes people's brains a little bit better, so they don't have to guess whether they're dividing or multiplying by certain things. So 4 kilometers per hour. I'm going to need to do 2 steps here. I need to change the kilometers to meters, and I need to change the hours to seconds. So this is going to be 2 steps. Let's do the kilometers first, but it really doesn't matter. You can choose whichever one you want. The order does not make a difference. So I have kilometers on the top, and so to cancel out the kilometers, I put it on the bottom, and I change it to meters. So 1 kilometer is 1,000 meters. That will take care of my kilometers. And then I need to get rid of the hours. But notice that hours is on the bottom of the unit fraction over here. And so to get rid of it, I need to put it on the top. So hours goes on the top. I want to switch it to seconds. So 1 hour is 3,600 seconds. And so now I can cancel out my hours because I have one on the bottom and the top. And so now what I end up with is meters on the top, that's the only unit that's left, and seconds on the bottom, that's the only unit that's left. So now it's 4 times 1,000 times 1 divided by 1 times 3,600, or 4,000 divided by 3,600. And 4,000 divided by 3,600 is 1.1 meters per second. That's unit conversion.